Okay. Our next speaker is Alexander Timofeev. Alexander is a serial entrepreneur in high-tech startups and a venture builder with more than 20 years in the industry and a vast technical and business experience in industries such as nanotechnology, autonomous systems, and super hard materials. Prior to founding Polyn.ai, Alexander founded Eyeglass Technology, a company that developed novel electronic smart glass technology. He built a core team and product concept that successfully sold the company in 2020. Alexander is also the founder of and a manager at the FPI Innovation Fund Venture Capital, an early-stage venture investment management company. The fund focuses on earlier-stage innovative companies, developing clear product concepts and strategies and working with venture firms and partners for subsequent funding rounds. As a manager partner, Alexander is responsible for greenfield development from early stage to growing businesses. Please welcome Alexander.
Yeah, good evening. If I know that I will send a much short introduction, yeah. Thank you for attention. First of all, I want to explain where we focus with our technology platform as a Polyn. It's a lot of discussion today about edge sensor data pre-processing. We also focus how to solve problem of efficient pre-processing of raw data. We have dozens of various sensors, and the number of sensors is growing. Microphone, cameras, event-based cameras, etc. All of the sensors generate raw data, and we need to extract useful information and as much possible more efficient way to do this. The classical way, what we use today, it's a sensor, analog front-end, pre-processing, various type of pre-processing using DSP or other type of conditioning, and then various digital system for extract information and then make decision what to do with this information. Our idea to change this environment, to split for neuromorphic front-end, which is based on analog neuromorphic core, and use all of pre-processing, including signal conditioning, feature extraction, reduce this raw data tsunami to very, very tiny flow of useful data, and then digital system only make decision or classification of data. We develop a new platform to solve this problem. It's a special compiler based on our fundamental research, generates more than 10 years ground mathematical research behind this, but finally it's a very simple and efficient tool. It's a compiler which take traditional digital model in any format. We split, our idea is split neural net training and inference. For most 99 application focusing on sensor data processing, you don't need update your model on chip. So you can train it in digital environment, that's what all of you know perfectly. And when the digital model is fully satisfied your result, then we can use compiler, which convert this digital model to analog neuromorphic core. What does it mean? That our final structure on chip consists only analog neurons. This is a special kind of operational amplifier, connection, and weights. Weights representing as a fixed resistor array, so it's like a ROM memory, so it's a fixed structure. And that structure works with analog data representation. So it means we don't have cycle, don't have memory, no digital information at all. We have analog input vector input and analog output with one inference, which is typically take few microseconds. Average time it's 3-4 microseconds per inference. So it's ultra low power consumption and ultra low latency. And what is interesting, the latency, it's not depend of neural net size. So you can take 2 times bigger structure and have the same latency, because that is only time of analog signal propagation through this structure. I can explain in interesting examples how we can use this platform, because the platform works. We already made first test chip, but finally what application, how to use this platform. First, our ongoing application is a voice activity detection chip. We built this chip in cooperation with a Deep Hearing company based in Korea. They are also represented here. Finally, we will have unprecedentedly low power consumption, below 30 microwatt in always on mode, and 90% voice recognition in noisy condition, in SNR around 0 dB, which is very difficult for standard solution. That is the first product, and second product, which is ongoing and we launch next year, vibration signal pre-processing. That is very, very important task for predictive maintenance industry, to extract feature from vibration signal for wireless solution. Vibration is noise, so 99.9% information, it's just a garbage. So you need to extract feature from this noise signal. And now predictive maintenance industry send all this raw data to cloud, use big model to extract feature and detect conditions of your devices. But that solution, it's not working in task where you need on sensor data processing. Like example, smart tire application. If you need detect online surface condition, dry, ice, snow, you need process data on sensor inside the tire with few microwatt power and no chance to transfer raw data to the cloud also. So that is an example of how difficult it is to process that signal. For tire monitoring, you need to take approximately 10 kilohertz accelerometer bandwidth. That bandwidth in 2 axes generate around 1 megabit per second raw data, and no technology which can allow you send this data from wheel to inside the car dashboard to processing. So need solution to process this data on sensor. We use wavelet pre-processing for this task, not use commonly working FFT, because that is required a lot of neurons and bigger structure, and we don't need linear quality of whole bandwidth processing. For example, for high frequency part of the spectrum, we can use less resolution. For low frequency part, higher resolution. So wavelet segmentation for wavelet processing works much better. We build this digital model, train it in rich data set, and here is the result, how we can structured output which consists only 24 bytes. So the input, it's 24 kilohertz sampling rate, so it's 24,000 bytes per second coming from one axis accelerometer, and output it's 24 bytes per second, so it's a reduction data more than 1,000 times. But you can see anyway this small output can very well clustering. We use different type of classificator, and the output data is well clustering, and we can define condition of monitoring devices with accuracy around 95%. So 95%, which is more than enough for most application. Here is video showing the raw data flow from standard sensor and data flow after pre-processing using this structure. But you can see the clusterization of the condition is very well, so we can very easily detect the two different conditions with devices in real noisy. This is noise transducer, so it's a very noisy signal, and system can very well recognize different conditions. So that chip will be available in 2024 with trademark VibraSense. The first application will be for smart tire to upgrade standard pressure and temperature monitoring sensor node to smart sensor node, which can detect surface condition, tire condition. And you can see if we go straight and just put the raw data transmitting the existing structure, just add to existing structure accelerometer. They will drain battery for a couple hours. If we use digital pre-processing, we use the same model as we train it, but in standard digital low power pre-processing. It's much better. It's 30 days, but anyway, 30 days is not enough for you if you if you will need to change battery in your car in all wheels every month, so that not fly. But if we use analog neuromorphic pre-processing, it consumes less than 100 microwatt, so we can use energy harvesting power source without battery at all. So the analog neuromorphic open opportunity to pre-process in level not milliwatt, but in a range of from 50 to 100 microwatt level with very rich signal, so 24,000 samples per second, so it's a huge data flow. We developed two chip architecture. One is a light version, so the slave model which work together with existing sensor node, so sensor node which have small MCU RF transmitting, and we just add our die to pre-processing of the accelerometer data. And second, it's more complicated with small MCU which can work as a master, so we can use very simple RF transmitter like a LoRa or 433 megahertz transmitting for industrial application. So that open other markets instead of only smart tire, but also a lot of other industries where predictive maintenance today not adapt because it's a cost prohibitive. Today's solution, it's only adapted for like power plant, aircraft, helicopters, so very expensive industry where the cost of predictive maintenance it's affordable. But for car, for example, for commercial car, they want to have this type of sensor node, but just not ready to pay the today price. Our solution also very cost efficient, so because very single chip, very simple structure, and sensor node which can work for many applications. We work for other sectors. Now we focused on voice processing, vibration processing, and biological signal processing like PPG signal for heart rate monitoring, accelerometer data processing for human activity recognition. So that is three directions where we now build our products. So thank you, and I'm ready to answer.